Hi everyone, I'm David Wismer, and I'm a recent graduate of the Metis Data Science Bootcamp. Today I want to show you a project that I worked on during the classification module, or the supervised learning module. And my project is called Genrify. Genrify is a web application that uses the Spotify API and classification techniques to predict EDM subgenre classification for a song based on its audio features. I built in several tools to the app. The first is a recommendations classifier, so you can give seeds to the app and it will return Spotify recommendations, 100 of them in a list, each classified for their subgenre classification within EDM. There's also a playlist classifier for which you can give a unique identifier for a playlist in Spotify, and Genrify will return the subgenre classifications for every song in that list, as well as a percentage breakdown. You can also give it an individual track, and the app will give you the classification of that single song. Some use cases might be an EDM artist who wants to understand what does Spotify recommend when given my own music as a seed. Or a listener, for instance, a country music fan might want to put in country as their subgenre and see if it returns 100 Spotify recommended songs related to country, what are the EDM subgenres of these songs, to thereby understand what kind of EDM subgenre might I like as a country fan. Also, you might be able to give it a playlist URI for a festival that's coming up and understand what is the percentage breakdown by EDM subgenre of this upcoming festival. Here I'll go through my data pipeline. It all began with Spotify data. I used Spotify, a library that allows you to access the Spotify API and get audio features. I brought that into a Python environment where I use pandas and NumPy for EDA, feature engineering, class balancing. I built several different machine learning models using scikit-learn. I pickled my favorite of those and passed it to Streamlit, where Genrify was then created. Here's a list of audio features that Spotify has for each of its tracks, things like acousticness, speechiness, instrumentalness. Some of these are much more useful in actually separating EDM songs than others. And the three are tempo, danceability, and loudness. First, looking at tempo. And by the way, along the bottom here, you see our first look at the different classes of EDM music: drum and bass, deep house, dubstep, hardstyle, progressive house, and you can't see the last two, but they're techno and trance. And here with tempo, what we see is that the interquartile ranges in these box plots are actually quite nicely delineated, meaning that we should be able to separate songs into their subgenres using tempo fairly well. Danceability, less so, but still enough to work with, such that if we have edge cases where we can't get the job done with tempo alone, danceability could be helpful. And the same is true of loudness. Not as much separation as tempo, but still something we can work with. Now I'll talk about my modeling workflow. First, I took several different classification algorithms and just kind of tried them out of the box in a baseline evaluation. And from there, 3 emerged as clear candidates. These were XGBoost, Random Forest, and Support Vector Classifier. From there, I did tuning and validation on these 3 candidates and ultimately selected Random Forest for my final model. And the reason for this was a balance of accuracy and simplicity. So I know it's weird to say that Random Forest would be a simple model, but when you compare it to XGBoost, I find it easier to explain. And the accuracy boost from XGBoost was not enough to warrant the additional complexity. In addition, the Random Forest model that I did select allowed me to get rid of several dummy variables that would have required additional pre-processing with the data in the app, and avoiding that pre-processing speeds up the application as well. So now I'll move on to my model evaluation. The training score for the Random Forest model was near 100%. The cross-validation score and testing score were right around 76%. And here on the right, we see a confusion matrix that shows where we're getting it wrong. This first is normalized by actual classification. So you see the true classification is on the y-axis, predicted classification on the x-axis, and the rows sum up to 100%. So here we see for dubstep, for example, 69.2% of the time, that it truly was dubstep, we got the prediction correct, meaning that 31% of the time that a dubstep song was fed to the algorithm, it actually got it wrong. And now we look instead at the columns adding up to 100%, so normalized by prediction. And in this case, deep house, and you can't see it, but techno are the big offenders. So for techno, 63% of the time that we predicted techno, we were correct, meaning that 37% of the time that we predicted techno, we were actually incorrect. So what is it about these offenders that is giving us so much trouble? What we see here are our top three features in the model: tempo, danceability, and loudness. This is in terms of feature importance in the random forest model. And what we see is that for techno in particular, if we focus in on that, it's the orange line. We see that the distribution is actually quite spread out. Whereas if you look at in the first graph, for instance, for tempo, you see on the far right for drum and bass, the blue line, it's nice and tight, meaning the distribution is really not going to be too spread out, and it's something that we can use very nicely in our classification problem. And the same is true for danceability and loudness. The orange line again is techno, and we see that it's very spread out, which means that we don't really have a whole lot to go on in terms of classification criteria for techno in particular. Now I'd like to go through a quick demo of the app. So we'll start here on the recommendations classifier. You can see there's a menu for these others as well. What we'll first do is grab an artist URI, and we'll grab Above and Beyond. So if you get the URI and paste it into Genrify and click the button, what you'll see is a list of recommendations related to Above and Beyond, 100 of them. And on the far right, you see the genre prediction. You're seeing lots of progressive house, lots of trance. Makes sense. Above and Beyond is a very famous trance artist. Trance is 56% of the music that was recommended. Now let's instead enter a genre. Like I said before, we could enter country. So if we enter country and click Genrify, we're going to see a bunch of country songs pop up. You know, things like Leanne Womack and Kenny Chesney. We're getting genre predictions, a lot of deep house, decent amount of dubstep. So maybe a country fan might want to look into those as genres that they might enjoy. We'll move on now to the playlist classifier. So let's grab a URI for Deep House Relax. You can guess what should show up here. If we paste it in and click Genrify, we'll see that the genre breakdown is 65% deep house, 27% progressive house, and then on down the line, very low percentages. So for future work, I'd like to expand Genrify to different music genres with several subgenres, things like hip hop and R&B, country, jazz, classical. I'd also like to work with a web developer to launch a global application. What you've seen so far is local only. There's some difficulties with the Spotify authentication process within Streamlit, but I am working on it to get it going and launch a global application. And finally, I'd like to make use of lyrics, song and album names, and maybe even album art within the classification model to see if I can boost performance even further. So thanks for your time today. If you have any questions, if you're interested in how I built this model, you can check out my GitHub. You can see my code review video that I've also posted on my YouTube channel, or you can reach out to me directly in the comments. Thanks again.